Mars, a landscape of extremes. Named after the Roman god of war, Mars is the red planet. Scientists and observers from Earth have long been fascinated with Mars, because it is the one place in the solar system that is most like the Earth. A common thread that underlies our intense interest in this planet is the search for extraterrestrial life. From observers in the 19th century who thought they saw canals on Mars, to the mesa that was mistaken for a face, to the Viking mission experiments looking for life in the soil, humankind has wondered about and investigated the possibility that this most promising planet may harbor life. We have been studying the planet from space since the 1960s. The Mariner series of spacecraft that visited the planet during this time quickly verified that there are no canals on Mars. However, what we have discovered there boggles the mind. Mars, although more Earth-like than any other planet, is a destination of extreme landscapes. It has the largest mountain in the solar system, Olympus Mons, which happens to be an extinct volcano. Olympus Mons is 340 miles across and has a caldera large enough to place the island of Oahu inside. Mars has a giant canyon, Valles Marineris, which is 3,000 miles long. This canyon is so large it would fit across the United States if it were here on Earth. And the Grand Canyon would be like a minor tributary if it were on Mars. Mars has a very thin atmosphere, with an atmospheric pressure 0.7% of the atmospheric pressure we experience on the Earth. In fact, there is not enough atmospheric pressure for liquid water to exist on the surface of the planet. Water would freeze immediately upon entering the atmosphere from underground. Mars has a pink sky instead of our Earth-like blue sky due to the iron-rich Martian sand and dust. But the most interesting investigation we have undertaken is the search for water on the red planet. The mantra that NASA has developed in exploring Mars is that if we follow the water, we might find life on this planet. The Mariner photographs from the 60s and the 70s showed scientists the initial evidence for ancient flows of water in the southern hemisphere. There is a region in the southern hemisphere that is a landscape that was carved some 4 billion years ago. We can tell that from the density of craters. What we see here are formations that look like tributaries of rivers that might have been formed by precipitating water. These landforms were our first evidence of ancient water on Mars. The discoveries pushed scientists to the conclusion that if there was water flowing on the surface, the atmosphere must have been denser in the past, since it is too thin now to allow water in a liquid state. The discoveries also spurred interest in sending a lander to Mars to look for signs of life. In 1975, NASA launched 2 Viking series landers to opposite sides of the planet. Viking 1 landed in the Crowe Planitia, the Plains of Gold, in 1976. And a few months later, Viking 2 landed in Utopia Planitia on the other side of the planet. Soil samples were scooped up, and chemical analysis was performed to look for evidence of life. Unfortunately, the results of these life experiments were very ambiguous. At first, they did see some activity, but the conclusion was that the results were actually due to an excess of oxygen in the soil and not compelling evidence of the presence of life forms. So, no life in the soil of Mars. Mars isn't as interesting as we thought it was after the Viking missions. So, interest in exploring Mars waned for about 17 years, and then something happened. A meteorite that had been found on the Antarctic ice fields in 1984 was analyzed in 1993. The results indicated that this meteorite was a rock that had been blasted off the surface of Mars and somehow ended up here on the Earth. Scientists also found strange little tubules shaped like bacteria in this meteorite. They referred to these as BSOs, or bacteria-shaped objects. Immediate interest peaked once again to search for life and water on Mars. Although experts later concluded that the BSOs found in this meteorite from Mars were more likely contamination from sitting on the Antarctic ice for so many years. Nonetheless, the push was on, and humans would be going back to the Red Planet to look for life. However, gone were the days of the expensive spacecraft that cost billions and billions of dollars. NASA's goal was to devise a low-cost mission. The result of this effort was Pathfinder. On July 4, 1997, Pathfinder landed on the surface of Mars in a place called Ares Vallis. This site was chosen because it was thought to be an outflow channel carved into the surface of Mars by ancient catastrophic floods. The floods were likely caused by huge discharges of groundwater at the channel heads. Pathfinder had on board a little robotic rover called Sojourner, which was able to explore a very small area around the landing site looking for signs of water. Sojourner found signs of erosion in rocks, of material leached out of rock by water, and exposure to water. The conclusion from this mission was, yes, this area of Mars was probably exposed to water at one time or another, most likely in the ancient past. An orbiter called the Mars Global Surveyor was launched from Earth on November 7, 1996, and began orbiting the Red Planet on September 11, 1997. NASA hoped to get 1 year of service from the spacecraft. Mars Global Surveyor has now lasted over 10 years, sent back more than 240,000 images to Earth, and is considered the most productive science mission to Mars thus far. Tom Thorpe, project manager for the project at JPL, said, "It is an extraordinary machine that has done things the designers never envisioned, despite a broken wing, a failed gyro, and a worn-out reaction wheel." A few of Mars Global Surveyor's many important discoveries about Mars include the following. Laser altimeter measurements have produced an unprecedented global topographic map of Mars. The instrument revealed a multitude of highly eroded or buried craters too subtle for previous observation, and mapped canyons within the polar ice caps. The spacecraft's camera found gullies cut into many slopes that have few, if any, impact craters. This indicates the gullies are geologically young. Scientists interpret this as evidence of action by liquid water, essentially in modern times. The mineral mapping infrared spectrometer found concentrations of a mineral that often forms under wet conditions, fine-grained hematite. This discovery led to selection of a hematite-rich region as the landing site for NASA's Mars Exploration Rover, Opportunity. The magnetometer found localized remnant magnetic fields, indicating that Mars once had a global magnetic field like Earth's, shielding the surface from deadly cosmic rays. The camera found a fan-shaped area of interweaving curved ridges. These features provide the first clear smoking gun evidence that some valleys on Mars experienced persistent flow of a liquid with the physical properties of water over an extended period of time, as do rivers here on Earth. A long life allowed Global Surveyor to track changes through repeated annual cycles. For 3 Martian summers in a row, deposits of carbon dioxide ice near Mars' south pole shrank from the previous year's size, suggesting a climate change in progress. The impetus to continue our quest to find life on Mars went on with the advent of 2 more rovers called Spirit and Opportunity, sent to the surface of Mars in 2004. Both used the same landing technology as did Pathfinder, a huge inflatable bag that bounced around on the surface until it stopped and then opened up like a flower to expose the rovers. These rovers were amazing engineering marvels in that they were only supposed to last for about 90 days. Yet they have now been there for almost 3 years and are still functioning. They have trekked as far as 2 miles from their landing sites and managed to avoid large rocks and falling into large craters. One of the first things Spirit discovered was what scientists dubbed blueberries. These are really iron-rich nodules that have been eroded by water, sort of like pebbles at the bottom of a stream that have been polished, smoothed, and rounded out by constant exposure to water. In its journey, Spirit encountered rocks and landforms, which scientists had fun giving nicknames to, such as Home Plate and Husband Hill. Opportunity is in another part of the planet called the Meridiani Planum, near Gusev Crater. Opportunity found a rock that had been split by water. The rover is also skirting a large crater called Victoria, and scientists have given nicknames to the places along that crater's edge, such as Duck Bay and Cape Verde. These are real places on Mars that may be visited at some future date by humans. Actually, Opportunity is skirting Victoria Crater looking for a way to get down into it. This could be a dangerous proposition, as the rover may never get out again. We currently have 4 spacecraft orbiting the planet: the Mars Global Surveyor, the Mars Express, the Mars Reconnaissance Orbiter, and the Mars Odyssey. The Mars Express has viewed the famous face on Mars up close and revealed it to be a mesa, similar to features found here on Earth that are produced by sculpting winds. It has also revealed buried treasures in the northern hemisphere of Mars. The circles and ovals on this diagram are places that have sustained large impacts billions of years ago, which scientists think may have triggered volcanic outpouring that then covered over the northern hemisphere. Some of the biggest crater basins are in the north. It is thought that these impacts were also responsible for the loss of Mars' denser atmosphere as it was blown off the planet due to these huge impacts. The Mars Reconnaissance Orbiter has taken close-up views of an ancient lake bed in Valles Marineris called Candor Chasma. All the orbiters have taken many images and provided definitive evidence that, at least in the past, Mars did have water. But what about water on Mars right now, in the present? Photos from the Mars Global Surveyor have recently been analyzed, and it was noticed that images from the same location, taken 6 years apart, provided very exciting evidence for water on Mars in the present. The image on the left was taken in August 1999, and the image on the right was taken in the same area, the side of a crater, in September 2005. You can clearly observe the ice flow in the later picture that was not there in the earlier image. These new findings heighten intrigue about the potential for microbial life on Mars. Human exploration of the Red Planet thus far has been a story filled with curiosity, intrigue, excellence in engineering, starts and stops, and surprises. Some of you watching this may be young enough that someday you too might have an opportunity to visit or work in the extreme landscapes on Mars.